Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss Heron's formula. In this chapter, we are going to discuss the concepts of exercise 12.2. Okay, my dear children, are you ready to listen the class? Right. See the first point, area of a triangle. You have already learnt these points. We have already learned these concepts, but just for recall the previous knowledge. I am giving these concepts for the exercise 12.2 because we use these points very frequently to solve the questions in exercise 12.2. Okay, my dear children, right. See the first point, area of a triangle is equal to half into base into height. Okay, my dear children, do you remember this formula? Right. Come to the second point. Area of a parallelogram is equal to base into height, where height is the distance between the parallel lines. Okay, my dear children, we define height of the parallelogram means the distance between the parallel lines. Okay, my dear children, right. Now come to the third point, Pythagoras theorem. We use this theorem also very frequently to solve the questions in exercise 12.2. Okay, my children. So, in a right angle triangle, side whole square plus side whole square is equal to hypotenuse whole square. This statement is said to be Pythagoras theorem. Statement of Pythagoras theorem. So, to understand this concept clearly, I am taking a rough diagram I have drawn, a right angle triangle ABC. See this point in the adjacent figure, triangle ABC is a right triangle, means right angle triangle at B is equal to 90 degrees. Okay, my children, I marked here. Do you understand this one? Right. Then by Pythagoras theorem, we get AB whole square plus BC whole square is equal to hypotenuse. What is hypotenuse in this triangle? AC whole square. Okay, my children, can you identify which side is said to be hypotenuse? The side opposite to right angle in a right angle triangle is said to be hypotenuse. Okay, my children, please learn these points well. Okay, my children, right. Now come to the exercise 12.2 sums, page number 206 in the textbook, page number 206. This entire exercise 12.2 is based on application of Heron's formula to find the area of different quadrilaterals. Okay, my children, application of Heron's formula for finding area of different quadrilaterals. Okay, my children, right. Come to the question number one. Question number one. A park in the shape of a quadrilateral ABCD has angle C is equal to 90 degrees, AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meters, and AD is equal to 8 meters. Understood this question, my dear children? Read the question well, my dear children, till you understand the question well. Okay, my dear children? Right. How much area does it occupy? We have to find the area of the quadrilateral. Understood the question, my dear children? Right. So for the given question, we have drawn a rough diagram. ABCD is a quadrilateral. In this quadrilateral, angle C is 90 degrees, and we labeled the lengths of the sides. AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meters, and AD is equal to 8 meters. Understood this rough diagram, my children? Right. So come to the solution. In the adjacent figure, ABCD is a quadrilateral with AB is equal to 9 meters, BC is equal to 12 meters, CD is equal to 5 meters, and AD is equal to 8 meters. Okay, my children. Right. So with these measurements, we can't find the area of this quadrilateral ABCD. So for our convenient to find the area of this quadrilateral, we are joining BD. We are joining these 2 points B and D. Then this entire quadrilateral is divided into 2 triangles. One is a triangle BCD, that is right angle triangle, and another one is ABD. Understood this diagram, my children? this BD, the line segment BD is dividing this entire quadrilateral into two triangles, of which BCD, triangle BCD is a right angle triangle and another triangle is DAB. Okay, my children, understood? Right. So join BD to get right angle triangle BDC. We got triangle BDC, right angle triangle. So easy we can find the area of triangle BCD. Area of triangle BCD is equal to half into base into height, because it is a right angle triangle. We can use this formula for a right angle triangle. We can use half into base into height to find the area of the right angle triangle. Understood this formula, my children? Right. That is equal to half into, here we can take BC is base and CD is height. Okay, my children? Or you can take CD as base and BC as height, as your wish. We get the same result. Okay, my children? Right. So in this formula, we are substituting the lengths of BC and CD line segments. Okay, my children? That is equal to half into, what is the length of BC? 12 into what is the length of CD? 5. Understood this step, my children? Right. That is equal to, we are striking out these two numbers, two ones are 2 6 times. Understood, my children? I am not doing here calculation. Do the calculation part in the rough work. Okay, my children? Right. Then what will you get here? 6 only. After cancellation, we get here 6 into 5. So I wrote directly here 6 into 5 only. Understood this step, my children? Right. Then what is the value of 6 into 5? 6 5s are 30. Okay, my children. After finding the numerical value, finally we had to write units also. What is the area of a triangle? Units of area of a triangle: meter square, centimeter square. According to this question, meters are given, so area is in the meter square. Understood this part, my children? Right. Now come to this triangle ABD. Triangle ABD. Can you find the area of this triangle ABD? No, not at all. We can't use the area of triangle ABD is equal to half into base into height. Why? Because this triangle is not a right angled triangle. Okay, my children, understood? If you observe this triangle ABD, it is not given that angle A is equal to 90 degrees. So it is not a right angle triangle. That is why we can't use the area of triangle is equal to half into base into height. Then what should we do? We have to find the length of the third side. We have got already length of the two sides. Now we have to find the length of BD in this triangle ABD. Okay, my children. So to find the length of line segment BD, we are taking the right angle triangle BCD. With the help of the right angle triangle BCD, we find the length of BD. Okay, my children? Understood? Right. So in right angle triangle BCD, BD square is equal to BC square plus CD square. By applying the Pythagoras theorem, we can write this statement: BC square plus CD square is equal to BD square. This is hypotenuse, because this side is opposite to angle, right angle. Okay, my children? Right. Understood this statement, my children? Right. This implies BD square is equal to, we don't know the measurement of the line segment BD. So BD square is equal to, what is the length of the line segment BC? 12. So 12 whole square plus what is the length of the line segment CD? 5 meters. 5 whole square. We substituted the length of the line segment BC and the length of the line segment CD in this equation. Then we got this step. Understood this step, my children? Right. This implies BD square is equal to, let us take this first term. What is this first term? 12 square. What is the value of 12 square? 12 into 12, 144. 12 12s are 144. Understood this first term, my children? Right. Plus come to the second term. What is the second term here? 5 square. What is meant by 5 square? 5 into 5. Then what is the value of 5 into 5? 25. So I wrote the value of 5 square directly here. Understood this step, my children? Right. This implies BD square is equal to, now we are adding these two numbers, 144 plus 25. What do you get here? 169. Understood this step, my children? Right. This implies BD is equal to square root of 169 because here BD square is there. If you are sending square to RHS, it changes into square root. Understood this step, my children? Right. That is equal to BD is equal to what is the value of square root of 169? 13. 13 square is equal to 169. That is why square root of 169 is 13 meters. Length of the BD is 13 meters. So we got the length of the line segment BD. So in this triangle ABD, we have already got AD 8 meters, AB 9 meters, and we found here BD length for 13 meters. Understood this point, my children? Right. So for this triangle ABD, we can find now area of triangle ABD by using the Heron's formula. When you know the measurements of the three sides, then we can use the Heron's formula to find the area of the triangle. So we are using the Heron's formula to find the area of this triangle ABD. Okay, my children? Right. First of all, what should we find? Semi perimeter, that is S. S is equal to AB plus BD plus AD. Sum of all the sides by 2. This is called, what is this called? Semi perimeter of triangle ABD. Do you remember this term, my dear children? Yes, that is equal to, in this formula we substitute the values of AB, BD and AD. What is AB here? 9 meters plus what is BD here? We found here 13 plus what is AD here? 8 whole divided by 2. Understood this step, my children? Right. That is equal to, come to the numerator, there are three numbers, 9 plus 13 plus 8. By adding these three numbers, what will you get here in the numerator? 30 divided by 2. Understood this step, my children? Right. Now we simplify this fraction. 2 ones are 2 15 times. Then what will you get here? 15 only. After simplification, after calculation, we get here 15 only meters. So perimeter, semi perimeter of triangle ABD is 15 meters. Understood, my dear children? Right. Therefore, area of triangle ABD is equal to square root of S into S minus AB, means one side of this triangle, into S minus BD, another side of the triangle, into S minus AD. Understood this step, my dear children? By Heron's formula, we wrote this step. Understood this step, my dear children? Right. That is equal to, in this formula, we substitute the values of S, AB, BD and AD. Then we get square root of, what is the value of S here? 15 into 15 minus, what is the value of AB here? 9. Okay, my dear children, understood this brackets? Right. Into S means 15 minus what is the length of BD? 13. Understood this part, my dear children? Right. Into S minus AD, that is S means 15 minus what is AD length? 8. Understood this step, my dear children? Right. This is equal to square root of 15 into, let us find the value of these brackets. What is the value of this number 15 minus 9? What will you get here? 6. Understood this value, my dear children? 6 into, let us simplify these two numbers. What will you get here? 15 minus 13, 2 into 15 minus 8. What is the value of 15 minus 8? 7. Understood this step, my dear children? Right. That is equal to, here 15 is a composite number. We are writing this composite number as product of prime numbers. So we can write 15 as 3 into 5. Okay, my dear children? Understood? Into, here 6 is also composite number. We can write as a sum of product of prime numbers, 2 into 3. Understood this part, my dear children? Into 2 is prime number. We write that number as it is, and 7 is also prime number. We write that number also as it is. Understood this step, my dear children? In this step, we wrote this composite number as product of prime numbers. Similarly, we wrote 6 as a product of prime numbers. Okay, my children? Understood this step? Right. After that, we write pairs. We are grouping the numbers which are having the same factors. So here 1 2 is there, here another 2 is there. So we pair them. 2 into 2 in what brackets, into here one 3 is there, here another 3 is there. So we pair them, we group them as one pair, into here only single 5 is there, only 7 alone. So we wrote these two numbers separately. Understood this step, my dear children? Right. That is equal to, here we are finding square root. So from these two, we take only one number, 2. Understood this part, my dear children? Right. Into here also two numbers are there. We take only one number, that is 3. Understood this number, my dear children? Right. Into square root of 5 into 7. We write the remaining part as it is. Understood this step, my children? Right. That is equal to 2 3s are, what is the value of 2 3s? 6 into root 5 7s are 35 meter square. Because this is area of a triangle ABD. So we are writing the units also. Understood this step, my children? Right. That is equal to 6 into, let us find the square root of 35. What is the value of a square root of 35? 5.916 approximately. It is not exact value, it is an approximate value. Okay, my children, do you know how to find the square root of a number by division method? Okay, my children, right, by using that method we find the value of root 35, then we got 5.916. Okay, my children, I'm not doing this part, we have to do that part in the rough work and find out. You get this number only. Okay, my children, understood this step? Right. That is equal to, now we have to multiply these two numbers. By multiplying these two numbers, finally we get 35.5 meter square. Understood this step, my children? This is a approximate value. Okay, my children. So here we got area of triangle ABD also. So actually what is the question here? We have to find the area of quadrilateral ABCD. But we divide this entire quadrilateral into two triangles. So if you add the areas of triangle BCD and area of triangle ABD, then we get area of the quadrilateral ABCD. Isn't it or not, my dear children? Right. Now come to the area of quadrilateral ABCD. Therefore, area of quadrilateral ABCD is equal to area of triangle BCD plus area of triangle ABD. By adding the areas of these two triangles, we get area of quadrilateral ABCD. Isn't it or not, my children? Yes. So we wrote this step. Understood this step, my children? Right. That is equal to, what is the area of triangle BCD? We have already found, that is 30 meter square, plus what is the area of triangle ABD? We found 35.5 meters meter square approximately. Understood this step, my children? Right. That is equal to, by adding these two numbers, what will you get? 65.5 meter square approximately, because we are taking this value an approximate value. So final answer also an approximate value. Hence, the park occupies the area 65.5 meter square approximately. Understood, my dear children? Right. Now come to the question number 3. Question number 3. I am not explaining the question number 2 because question number 2 is the same that of question number 1. Will you try the question number 2 yourself, my dear children? Try it. Question number 2 yourself, my dear children. If you have any doubt, ask your doubts and get your doubts clarified. Okay, my dear children. Now come to the question number 3. Radha made a picture of an aeroplane with colored paper as shown in the figure. Okay, my dear children. Find the total area of the paper required. So she made a aeroplane like this with measurements like this. Here 5 centimeters, here 5 centimeters, this side 6 centimeters, this length is 6 centimeters, and this length is 1.5 centimeters, this length is 1.5 centimeters, and here this is 1 centimeter, here also 1 centimeter, here also 1 centimeter, here also 2 centimeters. The entire aeroplane is divided into different geometrical figures. This is a triangle, this is a right angle triangle, this is also a right angle triangle. If you observe, this is a rectangle and this is a trapezium. Understood, my children? The entire airplane is divided into different geometrical figures. By adding the areas of all the geometrical figures, we get the area of the airplane. Okay, my children, required area of the paper required. Okay, my children, right. Now come to the first triangular shape area. For triangular area 1, we know length of the three sides. So let us assume that this is A, 5 centimeters, this length is B, 5 centimeters, and this length is 1 centimeter. Understood this point, my children? Right. Now we can find easily the area of this triangle shape area. So S is equal to, by using Heron's formula. Okay, my children. So how do you find the area of the triangle by using Heron's formula? First of all, we have to find the semi-perimeter of the triangle. It means S. Okay. So S is equal to A plus B plus C by 2. Do you remember this formula, my children? Right. That is equal to, in this formula, we substitute the values of A, B and C. What is A here? 5. Plus what is B here? 5. Plus what is C here? 1. Understood numerator, my children? Divided by 2. Understood this step, my children? We substituted A, B and C values to get this step. Understood this step, my children? Right. That is equal to, if you observe the numerator, there are 3 numbers. We have to add these 3 numbers. By adding these 3 numbers, what will you get in the numerator? 11. Understood the numerator, my children? Right. By 2. We wrote denominator 2 as it is. Centimeters, because this is a semi perimeter of a triangle. Okay, my children. Now come to the area of this part 1. Square root of S into S minus A into S minus B into S minus C. This is nothing but Heron's formula. In this Heron's formula, we substitute the values of S, A, B and C values. Okay, my children, understood this point? Right. That is equal to square root of, what is S value here? 11 by 2 into, what is S value here? 11 by 2 minus A. What is A value here? 5 into S minus B. What is S here? 11 by 2 minus, what is B value? 5. Understood this one, my teacher, on this part? Right. Now come to this part, third part. S means 11 by 2 minus C value is 1. Understood this part, my children? We substituted S, A, B and C values to get this step. Understood this step, my children? Right. That is equal to square root of, we write this first factor as it is, 11 by 2 into, now we simplify these two numbers in these brackets. If you observe these two numbers, they are fractions. One fraction minus a second fraction. Here fraction means 5 by 1. We assume that here denominator is 1. If no number is there in the denominator, we can assume that 1 is the denominator. So one fraction minus another fraction. How do you simplify? First of all, we have to take LCM of the denominators. What are the denominators here? 2 and 1. Then what is LCM of 2 and 1? 2 only. Okay, my children, understood this LCM of the denominators? Right. Then what will you get in the numerator? Previously, I told you how to write a numerator when you are adding or subtracting two fractions. I told clearly, assume that this is 2 table. This 2 table, how many times it goes in this number 2? 1 time. 1 into 11, 11. Understood this first term, my children? Right, minus. Here 1 is there. 1 table, how many times it goes in this number? 2 times. 2 5s are 10. Understood the second term, my children? Right. We found the value of this number. Now come to this brackets. We get the same because 11 by 2 minus 5, same numbers. So 11 minus 10 by 2. Understood this part also, my children? Right. Now come to the third brackets. Here also denominator is 1. So LCM of the denominators 1 and 2 is 2 only. Then 2 table, how many times it goes? 1 time. 1 into 11 is 11 minus. Here 1 is there, 1 table. How many times goes in this number? 2 times. 2 ones are 2. Understood this numerator, my dear children? Right. That is equal to square root of first factor as it is, we get 11 by 2 into, by simplifying the second factor we get 1 by 2 into third factor is also 1 by 2 into Fourth factor, we get 9 by 2. Understood this step, my children? Right. That is equal to square root of, we multiply all the numerators. 11 ones are 11, 11 ones are 11, 11 nines are 99, divided by 2 twos are 4, 4 twos are 8, 8 twos are 16. Understood this step, my children? Right. That is equal to square root of 99. Square root of 99 can be written as 9 into 11 by square root of 16. What is the value of square root of 16 value? 4. I wrote the denominator directly. Understood this step, my children? Right. That is equal to, we can write it as root 9 into root 11 by 4. Okay, my children, by using the laws of exponents, root a b is equal to root a into root b. By using that, we wrote the numerator. It is in the form of root ab. So root a into root b, by denominator we wrote as it is. Understood this step, my children? Right. That is equal to, what is the value of root 9? 3 into root 11 by 4. Understood this step, my children? Right. That is equal to 3 by 4 root 11. We can ignore the into symbol between these two numbers. So 3 root 11 means 3 into root 11 only. But we don't write into symbol between these two numbers. Okay, my children? By 4. That is equal to 3 by 4 into root 11. Just we wrote like this. Then what is the value of 3 by 4? 0.75. We converted into decimal number, then we get 0.75 into, what is the value of root 11 here? 3.3 approximately. By using the division method, we get this value 3.3 approximately. Okay, my children, understood this step? Right. Now we multiply these two numbers. By multiplying these two numbers, what will you get here? 2.5 centimeter square. This is the area of the first part. Okay, my dear children, understood? Right. Now come to the area of this second. Okay, my dear children? Right. Area of this is in the shape of rectangle. What is the area of a rectangle formula? Length into breadth. Okay, my dear children? So we can easily find out the area of this pot by using the formula length into breadth. Okay, my children? Right. What is the length here? 6.5 centimeters into breadth is 1 centimeter. So 6.5 into 1. What will you get? 6.5 only centimeter square. Understood this step, my children? Right. Now come to the area of this third part. Area of this third part. It is in the shape of a trapezium. In the shape of a trapezium. So I have drawn this trapezium separately here. This length is 2 centimeters. This length is 1 centimeter. This length is 1 centimeter, and this length is also 1 centimeter. So for our convenience, I have drawn a parallel line to this side. So it is a parallelogram. Opposite sides are equal. Isn't it or not, my children? Right. So this length is also 1 centimeter. So if you observe this diagram, this trapezium is divided into two geometrical figures. One is equilateral triangle because 1 centimeter, 1 centimeter, 1 centimeter, and the another one is in the form of a parallelogram. The entire trapezium is divided into two geometrical figures, namely equilateral triangle plus a parallelogram. Understood this point, my children? Right. Now let us find the area of this equilateral triangle. You have already found in the first question in the exercise 12.1. The area of an equilateral triangle is root 3 by 4 a square. Do you remember that formula, my children? Right. That is equal to root 3 by 4 into what is a length of the side? 1 whole square. That is equal to square root of 3 by 4. What is the value of 1 square? 1. Then finally what will you get here? Root 3 by 4. Okay, my dear children. Understood? Right. Now let us find again area of equilateral triangle by using the formula of into base into height. Okay, my dear children. But we don't know the height of this equilateral triangle. But we know the area of the equilateral triangle. Just we have found that is root 3 by 4 is equal to half into base 1 centimeter into height. Okay, my dear children. Understood this step? Right. From this equation, we are finding height of the equilateral triangle. So height is equal to root 3 by 4 into If we are sending 1 by 2 to this side, it becomes 2 by 1. Understood this step, my children? Right. So then 2 ones are 2, 2s are. So root 3 by 2 centimeters. We get height of the equilateral triangle is root 3 by 2 centimeters. It is nothing but height of the trapezium. Distance between the parallel side of the trapezium. Okay, my children. Then there is a formula for area of a trapezium. That is area of trapezium is equal to half into height into sum of the parallel sides. Remember this formula also, my dear children. Area of a trapezium, that is equal to half into what is the height we got here, height of the trapezium, root 3 by 2 into sum of the parallel sides. Here see there, these two are parallel sides, so 2 plus 1. Understood this step, my dear children? Right. That is equal to, by simplifying this part outside, root 3 by 4 into, by simplifying these two numbers, what will you get here? 3. Understood this step, my dear children? Right. That is equal to 3 root 3 by 4. Okay, my dear children, that is equal to, we can write this number as 3 by 4 into root 3. Isn't it or not, my dear children? Right. That is equal to, what is the value of 3 by 4? 0.75 into, what is the value of root 3? 1.732. Okay, my dear children, you have to calculate these values separately in the rough work. Okay, my dear children? Right. Now we multiply these two numbers. By multiplying these two numbers, we get 1.2990 centimeter square approximately. Understood this point, my dear children? Right. Now area of 4 and 5, both are equal. Both have the same equal area. These are right angle triangles. So we can use half into base into height to find the area of this right angle triangle. So area of 4 is equal to half into base into height. That is equal to half into, what is base here? 1.5. 1.5 into height 6 centimeters. Understood this step, my children? Right. That is equal to 2 ones are 2 threes are. Then what will you get here? 1 3 into 1.5. Understood this step, my children? Right. By multiplying these two numbers, what will you get here? 4.5 centimeter square. This is area of 4 as well as area of 5 also. Okay, my dear children, we got the areas of each and every geometrical figure in this diagram. So therefore total area is equal to first area plus second area plus third area plus fourth area plus fifth area. Then we get the area of the entire airplane. Okay, my dear children, that is equal to, we have already found area of the first region, that is 2.5 plus area of the second region 6.5 plus area of the third region 1.299, area of the fourth region 4.5, and area of the fifth region also 4.5. Understood this step, my children? Right. By adding all these 5 numbers, we get 19.299 centimeter square approximately. Understood this, my dear children? Right.